Maintenance is a critical factor for the success of a company, where maintenance is a high cost factor. Up to 40% of the production costs are maintenance costs, sometimes even more. If a machine breaks down unplanned, this will lead to additional high costs. There's a lot of potential to optimize maintenance, and it's time to use modern and intelligent tools for this. And also with this to increase the machine availability and reduce your costs. Let me start with a short introduction of the current maintenance strategy of many companies. And this is probably also the case in your company. Mostly reactive or preventive maintenance strategies are applied. In reactive maintenance, action are only taken after the failure has taken place. This can lead to the long machine downtimes. Machines that are operated to the limit of their service life, the risk of damage is high. When we take a look at preventive maintenance, the goal here is to replace components before their fail. Here, components are replaced regardless of their conditions, but based on the time interval. It does not matter whether the machine has high or low utilization. These maintenance strategies are often used, but they are inaccurate and no longer up to date. By collecting machine data together with data analysis, the optimal time for maintenance can be defined much better. Furthermore, there are less undiscovered cases of higher wear and tear. Modern methods of data analysis, such as machine learning, are very helpful tools to optimize your maintenance processes. In this webinar, we would like to introduce you to the topic of data analysis with machine learning and artificial intelligence, and the relevancy to you. My colleague Hui will give you now an overview of the different methods of explain which methods are useful for machine health analysis and for optimizing maintenance. Later in the webinar, I will show you our powerful tool AirProgress, which contains the expert knowledge and with which you can easily apply this. This allows you to increase machine uptime and reduce costs. And now I will hand over to my colleague Hui.
Today I'm honored to give you a short glimpse into this exciting topic. After this talk, should you have any questions regarding the technical details of the algorithm behind AirProgress, please feel free to contact the Ärzten Digital team or myself directly. You also have the opportunity to ask questions at the end of this presentation, and I look forward to answering them. I will now get into the subject matter of today, AI machine learning and its application and benefit for you, the Ärzten customer. The following topics will be covered. Starting, I will introduce AI machine learning, how artificial intelligence is achieved and how it works. Then I will introduce its application and the customer benefits from a mathematical, technical perspective. AI machine learning is the creation of algorithms that imitate human behavior and capabilities. It is known mainly for computer vision in autonomous driving and natural language processing, for example, in navigating in a car. This is all achieved via machine learning. The key element of machine learning in our context and use case today include anomaly detection, how to find non-usual behavior of a machine. Predictive maintenance uses predictive analytics to estimate when a piece of machine may fall so that corrective maintenance can be scheduled before the point of failure. After these two exciting topics, I will then go into further technical detail regarding machine learning and a sub-branch called automated machine learning, short AutoML. Anomaly detection is the capability to automatically detect errors or abnormal activity in a system and is a machine learning-based technique that analyzes data over time and identifies non-usual changes and behaviors. To achieve this, we need sensors in the machine to collect telemetry such as rotation speed, temperature, and so on. An anomaly detection model is trained to understand expected fluctuations in the telemetry, measurements over time, and to communicate this. Rules: if a measurement is outside the normal expected range, the model reports an anomaly that can be used to alert engineers and allow the problem to be fixed before the machine is damaged. Important is that we are alerted in advance here. Predictive maintenance techniques are designed to help determine the condition of an in-service machine in order to estimate when maintenance should be performed. This approach promises cost saving over routine or time-based preventive maintenance because tasks are performed only when warranted. Thus, it is regarded as condition-based maintenance carried out as suggested by estimations of the degradation state of an item or in the case of Ärztin machine. Manufacturing industries have been on a steady path considering these new methods to achieve near zero downtime, to have flexibility in the manufacturing processes and bioeconomical. Again, what are the prerequisites for a predictive maintenance project? To keep the machine with sensors and network. Ideally, this prerequisite should be fulfilled long before the project begins, because the more data available, also from the past, the more accurate the results will be. Now we come to the subject of machine learning. Where does the learning come from in term machine learning? The answer is from data. In today's world, we create huge volumes of data as we go about our everyday lives. The same applies for machines, and in this case, Ärztin machines. How could any analysis process using machine learning look like? One could rely on supervised machine learning.
Hui, sorry to interrupt you. I'm not so quite familiar with the term supervised in the context of machine learning. Would you please introduce us to the concept of supervised and unsupervised learning?
No problem, Arndt. Let me quickly define the concepts. Machine learning tasks can be broadly classified into two categories: supervised learning and unsupervised learning, based on whether or not the training data has labeled information, with classification and regression representing the former and clustering representing the latter. To explain, supervised learning means that we have a clear expectation of the output of the input sample after the model is trained, while unsupervised learning means that we have no expectation of the output of the input sample after the model is trained. I hope this brings clarification. And now I will go back to the main presentation. One could rely on supervised machine learning. Data is collected and labeled with the correct information. For example, the state of the machine, at the same time also data analysis, is used to get insight into the data, which will reduce the complexity of the model and improve the accuracy of the machine learning model. The labeled data is processed using a machine learning algorithm that looks for a relationship between the features of the sample and the labeled state. The algorithm is converted into a machine learning model, which is in turn applied to a running Ärztin machine. Machine learning is the foundation of AI systems and the way we teach computer models to make predictions and draw conclusions based on the data. algorithms or off-the-shelf services already integrated by some IoT manufacturers. They lack customized sensors in input data but provide a surface insight into the data. However, these tools are a black box and can only be customized to a relatively limited extent. Also, you get no interpretable results and are useless for you in the long run and cannot perform optimally on Edson machines. Publicly available machine learning programming libraries or algorithm building kits are suitable for rapid model development and often draw in interpreted languages such as Python. For the user, this means in-depth knowledge is needed in form of a data scientist to interpret this. Our next subtopic is AutoML. How can automated ML help us and make Edson machines better? Traditional machine learning model development is resource-intensive and it takes a lot of time to generate and compare different models. Using automated machine learning can reduce the time required to generate production-ready ML models while making the job more efficient. Automated machine learning automates the time-consuming and iterative process of machine learning model development. I, as a data scientist, can use it to generate efficient and productive models with quality assurance. I can define model pipelines to orchestrate model training, deployment, and management tasks. All in all, AutoML is one further way of enhancing the analysis process. In real-world situations, especially when little data are available, regression models are very useful for making predictions. How can regression-based machine learning models be used concretely? Regression works by creating a relationship between the variables in the data that represent the characteristics of the thing being observed and the variables we are trying to predict, for example, labels. Looking back at our machines, we manufacture them and want to know when they will be serviced next. In this case, our data includes sensor data and our label is the date. To train the model, we start with a sample of data containing features and known label values. So in this case, we need historical data from the sensors. Concluding, regression models are dominating labeled and supervised learning methods. Another supervised learning method is the classification. Classification is a form of machine learning in which you train a model to predict which category an item belongs to. Categorical data has distinct classes rather than numeric values. Some kinds of data can be either numeric or categorical. The time to run a race could be a time in seconds, or we could split times into classes of fast, medium, and slow categorical. While other kinds of data can only be categorical, such as a type of shape, circle, triangle, or square. Concretely, I use this method for Edson machines to predict machine whether or not it is damaged. This means that the machine is in normal or anomaly. And here the circle closest to my previous explanations regarding anomaly detection. I try to explain with more examples. A binary classification is a classification, for example, that contains two categories. We can label a machine as normal or anomaly. Class prediction is performed by determining the probability of each possible class in the form of a value, where the value is between 0, not possible, and 1, certain. The total probability for all classes is 1 because the machine is either working properly or working anonymously. Thus, if the predicted probability of not working properly is 0.3, then the corresponding probability of the machine working properly is 0.7. The threshold is usually 0.5, which is used to determine the predicted class. If the predicted probability of a positive class is greater than the threshold, then the prediction is classified as a functioning machine. AutoML can be used to implement this efficiently, showing that we have a 95% probability of correctly predicting the state of the test machine. In conclusion, and to wrap up today's webinar from my point of view, I have shown you the relevant use cases for Ärzte machines from a technical perspective. I have introduced you to the relevant background topics of anomalies, predictive maintenance, as well as machine learning and AutoML, so to give you a head start when evaluating these topics. With the technologies, we can not only perform anomaly of machines, but also predict the maintenance intervals of machines. Our machine learning models can always be iteratively updated so that the model can be more adaptable to changes in the scenarios. And now I hand back to Arndt, who will introduce you to AirProgress.
As my colleague Hui described, it is important to use the right methods for data analysis. Only if you use the right method, you will get a useful result. So you don't have to worry about these complex analyses. We at Ärzte Digital have implemented this in our powerful product AirProgress. Our data analysis team, with including Hui, has combined the different analysis methods to provide an optimal assessment of machine condition. We offer this in our product AirProgress with the digital services condition monitoring. The functionality is the use I would like to explain. AirProgress records machine data such as pressure and temperature together with the vibration data of the bearings at the stage and the drive mode. You can see this in detail in the graphic beneath me and see there the different sensors and hardware components that are included in the AirProgress hardware solution. I would be happy to discuss the exact details in a personal meeting with you. These data can be viewed very easy and clear in our web application Ärzte Digital platform. Inside, we use the most suitable machine learning analysis methods in our application. The results are displayed in clear informations in the Ärzte Digital platform dashboard in form of an easy to understand health index of the machine. With AirProgress and the Ärzte Digital platform, you get a powerful and easy to use tool that you allows well informed about the condition of the machine. With this information, you can easily optimize your maintenance process to predictive maintenance. The result is the machine runs longer and you save a lot of money.
Mr. Meyer is a maintenance engineer in a cement plant. In the cement plant, 3 delta screws with standard instrumentation and without extensive data monitoring are used for pneumatic transport. The machines are located over the whole plant area. The machines are an important part of the production process, and if there is an unplanned machine failure, there is a major disruption in production. Mr. Meyer therefore takes the subject of maintenance and inspection very seriously. That is why he goes to the machines every day to check that everything is okay, which takes a lot of time. Furthermore, he always replaces wear parts after the specified operating hours. Today, there was a bearing damage on a delta screw and an unplanned breakdown of the machine, which led to a production downtime of 7 hours. The production downtime ended up costing €12,000. Added to this were the repair costs of the machine. How could this happen? Due to an increase in production capacity, this machine was operated with a higher load than normal. Mr. Meyer had not perceived this correctly. As a result, wear on the bearings accelerated and the damage occurred. With AirProgress condition monitoring, relevant machine data is recorded together with the vibration data of the bearings. This data is automatically analyzed using high-performance data analysis techniques. Mr. Meyer would also not have had to inspect the machines on site every day. With the Ärzten digital platform, he always has remote access to the machine data, no matter where he is. In addition, he is informed of irregularities by email. The intelligent data analysis ensures that increased wear due to higher machine load is signaled at an early stage. Accordingly, Mr. Meyer can carry out maintenance in good time depending on the degree of wear. This not only reduces the risk of unplanned machine downtime, but also saves him time because he no longer has to inspect the machines on site as often. Time and costs are saved and smooth operation is improved.
Thank you for your participation in our webinar. We hope you enjoyed the insight into the exciting topic of machine learning and how it can be used to improve maintenance with AirProgress. We look forward to your feedback and we are available to help you implementing AirProgress in your company. Stay tuned. Now it's time to ask questions, and my colleague and I'm available for your questions to answer this. Hello, now we are on the live session with the Q&A. My colleague Hui and that I mentioned would like to answer questions that are in the chat. And yeah, before this, we hope you enjoy the webinar and get a few new informations about artificial intelligence, optimizing processes for your maintenance process and so on. And when I take a look on the chat, there are a few questions, and I start with the first question. It goes in the range of the part that I'm presented, and so the question is, can only Ärzten machines be analyzed with these analyzers or also others from other companies? At the moment, we are focused on Ärzten machines, and so currently we offer AirProgress and the analytics complete in the range of our machines, and for the future we are thinking about to take a look over in other machines and other manufacturers, but currently the system is only available for Ärzten machines. Next question is, can this also be retrofitted to old machines? Yeah, that's a good question. At the moment, we have a lot of customers with existing machines in the field, and for us, it's a big possibility to bring this nice features and functionalities to this kind of machines. And so we are offering AirProgress and the analytics not only for new machines. We have a very interesting retrofit solution where we can retrofit different machines with different possibilities for retrofit, and so it is possible to retrofit Hertz machines with our retrofit solution. Another question, yeah, it's another interesting question. It takes the topic costs. How much does the data analytics cost? The pricing of our AirProgress data analytics is depending on the machine size and the application. And so we have different prices, and the exactly prices we can give you when we know a little bit more about your application, the machine, and so on. But that you get some experience what costs are. Approximately the prices starts at 110 euros per month per machine, and then we have a range depending on different machines. Next question, I see that's more your part. The question is, what are the advantage of the Ärzten data science teams comparing to other teams? Hui, would you like to answer this?
Now I answer this question. As a technical team, we know the features of Ärzten machine better, and we can better communicate with other teams of Ärzten group. Yeah.
Okay. Yeah, thank you. And I see the next question is going further in your topic. Where is our data science team is a stage of progress?
We work mainly on data analytics and building machine learning models for our machines.
Okay. And next question is your part, Hui, too. What are your goals for the next steps? Yeah, interesting question.
Okay, yeah, okay. I just answer this question. Our role as a data science team is, of course, to provide more exact machine learning models and AI solutions for our customers.
Yeah, thank you very much. And I see there are coming new questions. There is a question, is there any sales roadmap regarding Ärzten ML technology? Yeah, we have a roadmap, and that's that we explained. That is actually status, and we go further with more and deeper analytics, and so we are in the process where we are learning more and more and making the system much more efficiency, and so we are on the roadmap, and that's the point. Yeah, then another question, how much is the general to share of software costs for predicted maintenance comparing to the hardware costs such as sensors? Yeah, and the hardware costs, when we take a look, they are one-time costs that you invest one time in the machine, and so the invest in the beginning is much more higher, and our other costs are then monthly costs, a monthly fee, and so the costs of the analytics and the digital platform as a software as a service is then depending how long you are using this, and so you have these separated cost structures. Yeah, another interesting chat question is, which sensors do I using? Yeah, we are using sensors, especially when we talk about vibration sensors from the well-known manufacturer IFM. And so they are connected directly on the points where the bearings installed. And for us, it's important to use high quality sensors with well-known manufacturers so that we get, especially for our analytics teams, the best data from the sensors. And so we take care that we have high quality sensors. And so the invest of this hardware components are very important and is one of the point of the success of the data quality and the solution at the end. Okay, yeah. When I take a look on the clock, I see time is running much more faster than we expect. And there are in the chat some other questions, but I see the time is running out. And we give you the chance to read and write the questions and the answers at the end. We give answers to all sended questions at the end, and so you get everything at information that you need and what you ask for. And now at the point, we want to say thank you very much for participation and hope you enjoy the webinar and get new ideas and new informations. And we are best prepared to support you and contact us or contact the colleagues in our subsidiaries in your country, and they make then the connection to us from Ärzten Digital Systems, and then we go deeper in details and bring then the best solution for your application. Thank you very much and have a nice weekend.
Expect performance.